In the last session, we learned that there is always a forecast error associated with any forecasting method we use. An error is basically the actual minus forecast. For naive method, for each stage, we have errors. In moving average method, we use a two-period method here. There is always an error for each stage again. We can find that in our past examples, we always have errors. So errors is something we try to minimize. There's another way to think about errors. Error actually provides us some information. Okay, if it gives us something useful, why don't we use that? That's the idea. And then we develop a new forecasting technique. We call that exponential smoothing technique. Let's go through this exponential smoothing technique using an example. Suppose first we are at the end of period 1. And actual demand is 42. There is no information available before period 1. For period 1, there is nothing we can learn from the past, so we don't do any forecast for period 1. Since we do not have any forecast for period 1, then we do not have any error here either. Okay, so basically period 1 is just the starting stage. We don't do anything about it. Now we move to period 2. At the end of period 1, we make a forecast of period 2. Okay, so period 2, the forecast comes from the period 1 directly. This is always the case. Okay, so forecast for period 2 equals to 42. Let me say this again. In exponential smoothing, period 2 always equals to period 1. That's the setup. Now, period 1 passed, period 2 passed as well. We have the actual demand for period 2, which is 40. The forecasted demand for period 2 was 42. The error equals to actual minus forecast, which is 40 minus 42 equals to negative 2. What we are trying to do here is to make use of the information in the arrows. For example, the arrow in the last period now, if the future is period 3, then the arrow in the last forecast is negative 2. So we write down arrow in last period equals to negative 2. Now we have a question. How much information does we have in that arrow in the last period? So we give it a weight. Let's say the arrow in the last period gives us 10% information. So we calculate the adjustment from the arrow, which is alpha equals to 10% times arrow in the last period. So alpha equals 10%, arrow in the last period is negative 2. We get negative 0.2. Our forecasting for period 3 now is very simple. It is the forecasting in the last period. What's the forecasting in the last period? 42. Plus adjustment from arrow. What do we get from the adjustment from arrow? In the last slide, we found it was negative 0.2. So 42 plus negative 0.2 equals to 41 plus 0.8. 41.8. That is our forecast for period 3. Let's do one more period. Now, period 3 becomes the past. And we want to know the demand for period 4. We use the same method, exponential smoothing. First, the forecast in the last period is 41.8, so it's easy. Plus adjustment from error. Adjustment from error equals to alpha times error in the last period. Alpha, as we set it up, equals to 10%. And the error in the last period is 1.2. So we plug in all the numbers, we finish the calculation, we get a 41.92. That is our forecast for period 4. Now it's a good time for us to slow down and do exercise to reinforce our learning. Again, this is about exponential smoothing. Here's the setup. We have past period 1 and 2. And we want to know about period 3. Now, the difference of this exercise from our example is we now want to rely more on the error information. We give it a weight of 40%. That means we're going to use 40% of the information from the error. In other words, error really tells us a lot here. Now, please stop this audio lecture and spend 5 to 10 minutes to finish this calculation. All the formulas are same as our example. The thing you need to do is follow the steps in the example and solve this exercise.